Hey there, welcome back to another NeoForge modding tutorial. In this video, we're going to make a solar panel that can generate electricity and transmit that in the form of RF or FE. To achieve this, we're going to cover two major topics in this video, and the first one is block entities, which allow us to store data to our blocks, and the second one is capabilities, which are going to allow us to transmit energy, items, or fluids between blocks arbitrarily. Right now, you're watching me create the block model for our solar panel. I'm also texturing it within Blockbench, and I'm going to save the model under our Resources and Models folder. I'm also going to save the texture we've created under our Resources and Textures folder, because we're going to use both of them. Let's review some of our concepts and also introduce some new ones that are important to understand before we actually implement. This is our model of blocks and how they're registered within the game. We know that we create a registry object for a new block. We create the client rendering data. And we can also create a block state definition to store very simple values about each location of the block in the world. What if we want to attach more complicated data to each location in the world? Let's say we want to store items in it, or energy, or even fluids. Well, block entities are the intended solution for storing more complex data or behaviors in specific blocks. Let's have a look at what a block entity is and how it's constructed. Now, block states allow us to store some amount of data, but they don't allow for the versatility and complexity that block entities do. For example, in Minecraft, furnaces are block entities because they store and persist items, and they also cook them and create results. Block entities can be split into two parts. We need to create a block entity type that represents this type of block entity we've made, and we're going to register this in a registry. And this type will link to some block entity class we've created, and this class will be instantiated for every instance of the block entity in the world. So every location will have a new instance of the block entity. And therefore, each location will have its own data and own behavior. In order to expose the custom data that lives inside of our block entity to other things in the world, this could be energy wires, it could be hoppers, it could be entities just trying to take things out, we're going to need to use capabilities. Now, capabilities are essentially interfaces that allow our block entity to be interacted with in an arbitrary way. Things that interact with our block entity don't need to know how we're handling our items or energy, they just need to know what we're going to do with it. Usually this is in the form of extracting or inserting items, energy, or fluids, and we can do this in a very dynamic way using capabilities. Alright, we're back in our project, and the first thing we're going to do is create the solar panel block class. So inside of our blocks package, I'm going to call it solar panel block. Now this is separate from the block entity, but it will be attached. We're going to make this class extend the base entity block, and that's saying that this block is going to be attached to some block entity class. Now we'll implement the default methods. You'll see we have one for creating the new instance of the block entity and another for retrieving a codec that references this block. We'll also create a constructor matching the super. And then we're going to make our codec. So let's make a public static final map codec. And you can simply call the simple codec method and then put in the constructor for your block. Now we'll return this in our method. We'll return to the new block entity once we've created our block entity. Now the other thing we're going to add to this class is to define the hitbox shape. Because our solar panel model doesn't take up the full block, we don't want the hitbox when you highlight it to be the full block. We want it to specify a custom size. To do this, we'll make a voxel shape representing the shape of our hitbox. You can use the static box method to create one. And I've already made a box of the right size just by looking at my model. You can see this is the first coordinate, and this is the second one, and it creates a box between those 2 points. Now I'm copy and pasting two methods in here. We have the getShape method and the getCollisionShape, and we're going to return both of these as the shape that we just created. Now let's create our block entity class. Inside of our block package, we'll create a new package called entity, and inside of that, we'll make our new class. Now this needs to extend a base block entity class, and there are some further concrete types we can extend down the inheritance line that are pretty useful. This is randomizable container block entity. We'll implement the methods it asks for, And we'll also create a constructor matching the super. In the getDefaultName, we can make a component linking to a translatable key. Make sure to add this to your localization file. Now we have a few methods that pertain to the items that are stored inside of this block entity, so we need to make a field for those items. We'll make a private non-null list of item stacks. Call this items and create it using this helper method. We only want one slot to be available in this case, so we're going to type 1. And we're also going to make sure that it's empty by default. In our getItems method, we can return that list. In our setItems method, we can assign that list. And in the getContainerSize, we can return the size of our items. Now you'll see we have a createMenu method. This is going to be used to create the GUI interface when we want to open this block entity. For now, we're going to leave it null because we haven't created our GUI yet. Now we've created the code side implementation of our item storage, but we need to make sure that this is persisted and saved to the world when you close it. There are two methods to implement to make sure that this happens. The first is the load additional method, and as it sounds like, this is what loads in your block entity. The second is the save additional method, which saves the contents of your block entity when they need to be persisted. Now we can grab these methods from the chest block entity class because all they do is save and load a set of items. As an exercise, try to understand what's happening with these methods. We have some tag which represents the data we're saving, and we load items from it or we save items to it. Now I'd like to add some kind of energy storage buffer into our solar panel. What we need to do is save the data for the energy storage within our block entity, and also provide a capability that allows other blocks to access it. Luckily, NeoForge has a class that does both of these things. It's called energy storage. We'll create a new field representing our energy storage. In our constructor, let's create a default energy storage object. You can pass in a number of parameters indicating the capacity, the maximum input or maximum output rate, but for now, we're just going to specify the capacity at 1000. We need to make sure we persist this data too, so let's add it to our load additional and save additional methods. To load our data, we're going to use energy storage.deserialize NBT. We're going to pass in our tag. We're going to assume the tag is stored under this key, which is energy storage. And this might be null, so let's make sure it's safe. Here I've retrieved the tag and I just check to make sure it's not null before we attempt to deserialize. We'll do the inverse in our save additional method. We put a new tag under the key energy storage, and we can serialize our energy storage. Now let's make a static method for retrieving this capability depending on which side of the block we're interacting with. Think of how hoppers can insert or extract but only from certain sides. We can do the same thing with how our capabilities are accessed from this block. I'm going to make a new static method that returns our energy storage interface, and we'll take in two arguments. One is the block entity itself, and the second is the direction that this is being accessed from. Now for our example, I want to make sure that we only allow interactions from the base of the solar panel, because that's the only flat surface on the model that's kind of attachable, but you could return any capability you want from any side. We'll say if direction is down, then we return our energy storage. Otherwise, return null. Now our solar panel should actually do something. We want it to generate electricity over time. To do this, we're going to attach a tick method that fires every game tick. Inside of this, we can increment or decrement our energy storage depending on the sunshine. We'll make a new static method called tickServer. This is executed only on the server side because all the other information is synchronized to the client. It'll take the level, the block position, the block state, and this block entity. Now let's make sure we are indeed on the server side by testing if our level is an instance of server level. To start very simple, we can just increment the energy storage inside of our block entity on every tick. Now if we look at our energy storage, we have extract energy and receive energy. These are the methods we're going to use to change the level of energy in our device. So we will receive energy, and we'll say 1 energy every tick. Now let's make sure it's daytime with level.isDay. And let's also make sure that we can see the sky, that it's not obscured. So we'll do level.seeSky and pass in the block position. Now we can register both the block and the block entity that we just created. First of all, open our blocks class and create a new solar panel block. Now because our block is not a full block, we need to make sure that we turn occlusion off, otherwise we'll see some weirdness when rendering. So we'll add the .noOcclusion method. Next, we need to create a registry for our new block entities. To do so, in our main package, we're going to create a class called block entities. Now, just like we've done a couple times before, we're going to create a new register. This time, it's of type block entity type. Create a new registry from the block entity type with our mod ID. Now it's time to register our solar panel block entity. We'll call block entities.register. As usual, we provide our name. And the next parameter is a supplier that creates our new block entity type. To do this, we just create a new block entity type, and this is going to take a supplier of our block entity and also the set of allowed blocks that we can attach this to. So for the supplier, we can pass it our constructor for our solar panel block entity, and we create a new set of blocks that are allowed. Now we have an error here because our solar panel block entity constructor is not quite correct. It's taking this block entity type argument, and we don't need to do that, so we'll remove that and hard code in our type. Also make this constructor public, and if we return to block entities, you can see that that error has been resolved. Our type isn't quite correct, so we're going to change the type of this object to a deferred holder with the generic block entity type as the first one, and the second type here is the specific block entity type referencing our solar panel. Now back in our solar panel block class, we can return a new block entity when it's requested. Don't forget to go back to your mods main class and register our block entity registry with the event bus. And we always need to make sure we register the corresponding item for our block. Now it's time to generate the client rendering data for our solar panel block. Inside of our models and block folder, we have our solar panel model that we created in Blockbench. We also have the texture that's being referenced in the model. Let's open the model and make sure that everything is correct. We need to make sure that the texture we're using points to our mod's namespace and it points to the right image. We also need to make sure that the parent is Minecraft block/block. Everything looks good, so let's go back to the model provider and actually generate. First, define the location of our model. Then we can create a simple block state generator with one state. Use the static method in block model generators to create a simple block from a model. Then register this. Now we need to create the corresponding item. We've generated our rendering data, and inside of our resources, you can now see the 2 new files that we've created. Last but not least, we need to make sure to attach the solar panel block to the tick method from our block entity. So to do this, we're going to override this method called getTicker, and it's going to take 3 arguments: the level, the block state, and the block entity type. If our level is on the server, then we're going to return our ticker. If not, we're going to return null. Now we're going to return a call to this static helper method called createTickerHelper, and we're going to pass in our server type, which is our block entity type, the client type, which we'll reference directly from our block entities types. Now the next parameter is just going to be the tick method that we implemented. So we'll reference our block entity and call tick server. That's all you need to associate the server tick to the actual block. We can also register our capabilities. To do this in our solar panel block entity class, we're going to add an event bus subscriber annotation with our mod ID, and it's going to be on the mod bus. Now we'll add a new method that subscribes to our registration event. That's the register capabilities event. Call event.registerBlockEntity and specify the capability type that we're registering. In our case, it's going to be NeoForge's energy storage. Then specify the block entity type. And lastly, we need to reference the getCapabilities method we implemented earlier. So anything that tries to pull energy out of our solar panel from the down direction will be able to, but we can't always rely on the other block pulling. Instead, we can also make sure that our block pushes energy out of the bottom. To do this, inside of our tick server method, we're going to look for any capabilities that are below this block. We'll call serverLevel.getCapability, and we are looking for the block energy storage capability with our position in the down direction. We should get some kind of energy storage back. And if we did, we're going to simulate an extraction. And use the amount from our simulated extraction to determine how much we should send to the other energy block. And use the amount of energy that was actually sent to determine how much to truly remove from our own energy storage. Small mistake here, we need to make sure that when we get the capability, we're not looking at our own block position. We want to be looking at the block below it. And this direction here is the direction on that block that we're looking at. So we're looking downwards at the block below us, which means that we're looking at the block below's upward face. So this will be up. Right now, energy can be extracted from inside of our block entity, and it can also be pushed out of the bottom face. But energy can also be inserted through the bottom face, so we might end up with situations where energy is being extracted and then immediately put back in. We want to make it so the bottom face for external factors can only be extracted from. To do this, I'm going to create another capability that wraps our energy storage, but can only be extracted from. I'll add a new iEnergy storage to our block entity. We'll call this energy extract. Now in our constructor, we'll initialize this. We're actually going to create a new anonymous class of this interface type. The receive energy will always do nothing, so it'll return 0. The extract is just going to reference our energy storage. For the sake of accuracy, let's instead return the energy stored inside of our main energy storage, and do the same thing for the max energy stored. Now let's return this extraction capability inside of our capability method. So here in get capabilities, we're going to instead return our energy extract. If we look at our project directory, in the root folder, we have a folder called run. And this is our game instance. So when you run the Minecraft save where it's saving your worlds and the logs when you're actually testing the game. So into our mods folder, I've downloaded and added the energized power mod, which just gives us some additional blocks like batteries so we can actually tell if our solar panel is working. So now I've booted up a test world and we see we have our solar panel and we can place it down in the world with our model. It looks quite lovely. I also have some supplementary objects from the energized power mod just so we can try these out. So I'm going to put down a battery. We can open it up and see that there is no energy in it. And I will attach a solar panel. Open it up now, we see that we are actively generating power. And it's interfacing with the cables as we would expect. If we try to attach a cable to one of the other sides where our capability is not available, it won't connect. Also, if we block our solar panel off so it can't see the sky, then we will see we're no longer generating any energy. And now we've reached the end of this part of the tutorial. If you've made it this far, congratulations. I hope that you have a working block at this point. If you don't, feel free to leave a comment and I'm happy to help where I can. In the next part, I'm going to teach you how to make a user interface that can take items and show your energy levels. Stay tuned for that. Hope you have a great day.